global map of technology today. You see Tesla dominating the roads, SpaceX conquering the orbit, and XAI pushing the boundaries of intelligence. But in the center of this empire, there has always been a massive, silent dependency. A single point of failure, the Silicon Gap. For years, Elon Musk has relied on external giants like Nvidia and TSMC to provide the brains for his machines. But the world is changing. Global supply chains are fragile, and the demand for compute is exploding beyond human capacity. Enter Project Terafab. It is not just another factory. It is a declaration of independence. It is the final piece of a puzzle that bridges the gap between earthbound AI and a multi-planetary future. What is Terafab?
Announcement to make, which is the most epic chip-building exercise in history by far.
Located in the heart of Austin, Texas, Terafab is a radical departure from how chips are made. In the traditional industry, the process is fragmented. Design happens in one country, lithography machines come from another, and fabrication happens halfway across the world. This is slow, and Musk hates slow. Terafab's core philosophy is vertical integration. Everything, from lithography mass production to logic, memory, and final packaging, happens under one single roof. Why does this matter? It is about the recursive loop. Imagine an engineer at XAI discovers a bottleneck in a neural network.
Turn science fiction to science fact. That's the glorious, exciting future that I certainly look forward to.
Instead of waiting months for a new chip order, they can tweak the design, burn a new mask, and have a prototype running in the same building within hours. This fail fast, fix faster methodology, which made SpaceX the leader in aerospace, is now being applied to the atomic level of semiconductors. The two pillars of Terafab. But Terafab is not building just one type of brain. It is architecting two distinct pillars of intelligence. First, we have edge inference chips. These are the workhorses for the Optimus humanoid robot and Tesla's fleet. They need to be ultra-efficient, low power, and incredibly cheap to produce. Because if you want to deploy 1 billion robots, you cannot afford a $10,000 processor in every unit. The second pillar is even more ambitious: rad-hard space-grade chips. Deep space is a graveyard for standard electronics. Cosmic radiation and high-energy ions can flip bits and fry circuits in seconds. Terafab is re-engineering silicon from the ground up, using new materials to ensure that the AI governing our future colonies on Mars or the Moon never skips a beat, no matter how hostile the environment. The scale of the ambition. This is a massive gamble, moving from software and rockets into the high-precision world of nanometers is a leap many experts think is impossible. But as we have seen with the reusable Falcon 9 or the gigafactories, Musk does not build to compete. He builds to redefine the scale of the game. Terafab is the foundation. It is the engine that will power every Tesla, every robot, and every starship. But the question remains, why now? Why spend billions on a factory when the world is already full of chip makers? The answer lies in a crisis that most people have not even noticed yet. A crisis we call the 2% problem. To understand why Terafab exists, we have to look at a devastating reality of the modern world. During his keynote, Elon Musk revealed a staggering statistic. All the chip factories on Earth combined currently produce only about 2% of the compute power required for our near future. We are entering the age of artificial general intelligence and mass robotics. The current global supply chain, led by giants like TSMC and Samsung, is designed for the world of smartphones and laptops. It is not built for a world where billions of humanoid robots need dedicated brains. Musk's logic is simple. We either build the capacity ourselves, or the progress of humanity hits a hard ceiling. Terafab is the solution to this 2% bottleneck. It is not just about making chips. It is about creating a new scale of production that the world has never seen before. The second reason for Terafab is purely economic. Right now, the cost of high-end AI chips is controlled by a few dominant players. If you want to build a robot that costs $20,000, roughly the price of a small car, you cannot spend $10,000 on the processor alone. By cutting out the middlemen and owning the entire production line, Musk can drive the cost of unit intelligence down to the floor. This vertical integration allows Tesla to optimize chips for specific tasks. While an Nvidia chip is designed to do everything, a Terafab chip is designed to do exactly what Optimus needs. This leads to massive power savings and lower heat generation. In the world of AI, efficiency is the only way to scale. Terafab makes intelligence a cheap, abundant commodity rather than a luxury resource. Strategic sovereignty. Beyond the math and the money, there is the issue of survival. We live in an era of geopolitical instability. Trade wars, sanctions, or any tension in the Pacific could paralyze the global semiconductor industry overnight. For an empire that spans from Earth's roads to the orbits of Mars, depending on a fragile, long-distance supply chain is a massive strategic risk. Terafab gives Elon Musk strategic sovereignty. It ensures that no matter what happens on the global stage, the production of the brains for Tesla, SpaceX, and xAI will never stop. Musk envisions a future where the lessons learned at the Texas Terafab are applied to the moon. In the vacuum of the lunar surface, with no atmosphere to interfere, and 24/7 solar energy, we can scale compute by orders of magnitude. Project Terafab is more than just a factory. It is the heartbeat of a new era. It is the bridge between our current limitations and a future of abundance. It is the engine that will turn science fiction into science fact. The machines are coming, the rockets are ready, and now they finally have the brains they need to take us to the stars. The question is no longer if we can reach the future, but how fast we can build it.